screen visible?
Yep, I can see. Acha, Arya, just wanted to ask, like the
Mhm.
Miro board. You are showing your Miro board. So can we
Mhm.
get that Miro board, or like what you have? Like I guess you would have everything in one page. So
Uh,
if possible,
yeah,
would you like to
sure,
share?
sure, I
Or
can share it. No worries. I don't
okay,
think
okay.
like it's more of a messed up slides.
Yeah,
So I'm writing
yes,
on the
yes, yes.
slide side.
Okay, okay,
If
okay.
it's
Yeah,
useful,
yeah.
I will share.
Just
No
for a quick
worries.
glance. Like sometime if I want to refer anything rather than going through videos, I'll just
Okay.
have a quick glance in the page and
Sure, sure, no worries. I
yes,
guess I
yes,
have kept
yes.
most of the things here itself. Uh,
Okay, okay, okay. Think you can
so
export
initially,
this.
yes, yes, I can export it and I will send you. No worries.
Yes, yes, yes.
Uh,
We'll open in our Miro.
Maybe few of the classes when I started.
Ha ha ha.
No, from the first class it's there. Maybe in
Yeah,
between
yeah.
some are missing. That's
Yeah,
fine,
no
right?
issues, no issues.
Okay, sure. Sure, I can share it.
Mm-hmm.
Because videos. So I promised for something, right? Let me just show you guys the output of the previously what I that I run that code, right? So I kept it running. So I was on vacation weekends, so I kept my laptop on and it ran for 3 days.
Okay, okay.
And when I got to see it today, it was still running. I just terminated the thing and
Okay, I think
yeah.
it
So
went
what
into
happened was
infinite
I didn't put
thinking.
up max price. Yeah. So within the code, I didn't
Mm-hmm.
put up this condition of max price. Okay. So it was retrying infinitely. So that was what happening. So I
Mm-hmm.
ran the code again. So I used instead of the type, uh, it's more of like 4 GB is of my RAM, right? Uh, so
Yes,
instead
yes,
of
yes.
using Llama 3.0, which occupies up 3 plus GB, so I used encoder, which occupies like or less than 2 GB.
Mm-hmm.
So now
Yes,
I
yes,
got
yes.
the response. So every time I'm getting the response, no worries. So I'm just converting that into a pandas frame. So here you can see like if you are printing a pandas frame, this is how it looks. But what you
Mm.
could do is you could directly instead of printing, so this is Google Colab, right? So the last variable actually
Yes.
prints directly. So if you
Mm-hmm.
just do df is my variable which contains this table, pandas table, okay? So which has this particular structure, the question, the golden context, retrieved context, and retrieval score. So this retrieval score column is actually done by two encoders. Okay, it is comparing the golden context. So for this question, what has to be the ideal
Okay.
context and what was the context that was fetched and how relevant it was, or also it matches with like here the golden context would have exact like exact references, right? Exact context. But in the retrieved context, it may have more like more unnecessary context, or there could be merge of like important context and unnecessary context because of since we are ranking it two and the second context, if everything is filled in first context, so the second rank also comes in. That may be
Okay.
irrelevant. Okay, for that also it can reduce the retrieval score.
Mm-hmm.
So zero is absolutely nonsense, and luckily we haven't got zero for any of our all the 10 questions. So we can say our RAG is working completely fine. At one case, we got like 0.25. That is fine. Other than that, the scores are looking good. No worries. So this was the thing which I couldn't run back then, and it took like 49 seconds to complete this whole thing. So that's why
Mm-hmm.
max retries is must when you are dealing with AI, or else imagine if it was a cloud provider
Yep.
and I put
It
up
would
my
end up.
plan with hours there.
Mhm.
So yeah, the second layer, which we are speaking of, is the main application, where since we have already got the memory now, the RAG, right? So how can we build
Mhm.
our desired chatbot from there? Okay, so that's
Yep.
so here is the core thing.
Mm-hmm.
So yeah, so we're just a second. Yes. So instead of like single particular prompt and all the context, right? So we could have made this as a complete RAG application where there
Mm-hmm.
is an retrieval happening and I provide context with a prompt and let the LLM respond. So problem with that was it was a mode of like I'm asking everything has to be done by a single
Mhm.
LLM, and if it hallucinates. That's it, right?
Okay.
So the response has no checkpoints, and there is no feedback that's been provided, and there is no loops that happening. Correct. So by decoupling it, right? So instead of a single LLM prompt, so what I'm doing is so I'm using a cyclic graph. Okay. So that is agentic AI, right? So yes, so let me speak on the architecture. But before that, so while exploring agentic AI, right, we studied something about state, okay,
Yes.
which was a
Yes.
dictionary which acted as a shared memory for all the agents in our system, right? Even for this, so we have the state, okay. So state could be anything. Here for us, it's a dictionary. So every time an agent operates, so it will update this dictionary, a variable within this dictionary, and referring that the next agent would work. And for
Mhm.
our sake, for this capstone project sake, right? So we are not using asynchronous processing because we don't need it here, right? So we have a linear structure that user comes in, he puts up his query, okay, and his complaint, we can say, and the RAG system, RAG actually grabs whatever the context that's needed, and now the agent tries to answer, and there is an QA agent which checks through the policies if the drafted email is correct. So it's a linear structure. So there was no asynchronous processing needed, and there can't be any asynchronous process in this particular flow, right?
Mhm.
So it is more of a synchronous flow where the previous action has to be completed in order to get the things done in the next iteration, correct?
Mhm.
So yeah. So again, here we have a state shared memory which has like a ticket, maybe ticket ID is there, and the category. So we have defined three categories. So among which our first supervisor agent has to decide which category it belongs to, and depending on that, the RAG system gets the context depending on that category. Okay.
Mhm.
And then the context is updated here within this dictionary, and then the draft comes in. Our final agent will try to create a draft email. Okay. Considering the policies, and the critic feedback will have both the context query and the draft, since all these things, all the three things, and it checks for context and the policy, the context that's been provided and the draft that's been created, right? So if it is contradicting or something, okay, so it is checking for that, and this critic feedback will be updated. If it is passed, no worries, it is passed and we get the output. If it fails, right, if there is a contradiction, then this will write up its feedback, and the draft agent will try to create a new draft considering the feedback and the context. Okay. So we
Okay.
will count the loops, how many drafts have been created, and if it is max three, even then, if the critic agent is not satisfied with the draft, it will terminate the loop and ask like human evaluation. Okay.
Mhm.
So currently, I just added a print statement saying human evaluation. In any application, it would be something like there comes an email. So we connect it to email and maybe provide an like employee or a team lead email and ask this LLM to pass this all this information in a mail so that we can record where the human evaluation is needed. Because stopping the execution just to get the human response could be tricky sometimes because unavailability, right? So we can't put the system on hold. So instead, we could do something like that. Yes. So we have three special agents where the supervisor agent, okay, and retriever
Mhm.
is this is a RAG. So
Retriever is okay, agent.
so if you could remember the node we discussed, right, in Agentic AI. Node is something which could be a simple Python function, or could be an agent, or could be an LLM call that's happening. Okay. So this
Yes.
retriever
Yes.
is actually my Python function, okay, which is getting the context from DB, right? So even this is called the node here, okay, and the drafter is our agent, which actually considers the retrieved context and the user query and try to respond, create a draft email for it to respond, okay.
Mm.
So adding up on email, so we can add up an email API. It's an API call, so we can do that. No worries. But I haven't done it here. But yeah, that could be like easy peasy thing to add on. So yes, how the things go is drafter node creates it, submits the draft, and critic node will evaluate it. If it is satisfied, yeah, it just responds with the final draft that's been created. If not, it will give a feedback, and this loops goes on for like 3 iterations max. Okay.
Mhm.
Okay. So yes, we are using not the local LLMs this time. Okay. So yeah, we faced few issues with the local LLM. So instead, what I could do is there was like free API calls which we can do for Groq and Gemini HuggingFace, right? So I used Groq for this particular project.
Okay.
So for QA instant, yeah, I guess I forgot to tell you. There is like two types of in agentic AI we can use homogeneous execution and heterogeneous execution. Okay, so where for all the agents that are available for that particular application, right? So we can use only single type of single cloud provider, okay, or single LLM. So this usually is called homogeneous execution. So where even the QA instance is a Groq model, let's just say, and the drafter is also Groq model and supervisor is also Groq model. Or we can use heterogeneous execution too. So where so we will be using more than one model. Okay. So let's just say drafter is like Groq, and I want to avoid bias here. Okay. So what I could do is I want to do a like simple cross validation in the process itself. So there I can use for QA instance of this particular so critic agent, right? So instead of using the Groq for critic agent, I could use Gemini reasoning model. Okay,
Mhm.
which should provide the feedback better. But when to use it comes to this point that so when you are building an application, let's say around finance or healthcare, right? So you need that cross model evaluation better. Okay, there should be no bias. There should be perfect sync with the facts, right? So for that you could use like heterogeneous models. That is one you can use for let's say Groq for retrieval, sorry, drafter agents, and Gemini reasoning model for uh,
Mhm.
the critic agent. Okay. So, but in most of the applications, we won't be dealing with like let's just say we are not dealing with applications like medical or finance. Okay, so there we could use only like single model to throughout for the critic and the retrieval. So why this thumb rule is? So this is because of TTFT. Okay, time to first token. So when you have an like handshake has been done for a cloud provider, right? So let's say Groq. I'm using Groq. So the first request goes in. There is a handshake that's happening, and that session actually stays for some time. Okay. So the second request would be processed much faster. So let's say in application like I have so earlier we discussed on one of the application, right? So where we had like 7 agents. So imagine all the 7 API calls that are happening like continuously, right? So at that time, so once I make that handshake, so there is no delay with the time to first token. So the response. So this basically means the fastest response that comes in much faster if it's a single cloud provider. Imagine the same application previously discussed, right? So for around 4 particular agents, we had like 4 critic agents, correct? So imagine it
Mhm.
switches between like Groq and Gemini again and again. So the application would face much more latency. Okay, the response would be great, right? So the response would be more
Right,
authentic now,
right, right.
but there is a delay, and we deal with applications where there sometimes we need authenticity to more. Okay, or the fact it has to be factual the more like medical or let's say healthcare, sorry, healthcare and finance. But in most of the applications, we don't need it, right? We need the fastest response. So there we could use homogeneous models. Okay, for everything we can use a single model, and we will be building QA test pipelines for the same, right? So there we can use cross model evaluation. From for that we can use let's say other model. So it won't be using every time, right? So only when GitHub push happens, only when the update happens, then only it runs. So that would be greater there. But yes, within the application, if you're using like heterogeneous models, yeah, be wary with the latency. It could increase the latency like a lot. Okay, that was the thing which I missed, I guess. check and wait now. So yes, for now, so we'll be using Groq for our models for both the QA instance and so because it is not of like that critical application, right? So you could use the homogeneous models itself. So I've used Groq Llama 3.18b instant. Okay, this is the model name which I've used. So kept the temperature 0, no creativity needed
Okay.
because it has to analyze the policies and response. I don't have to write the poet, right? So so yeah, that's it. So we will check with the flow. So I hope it's a simple flow, maybe. So as we have discussed much complex flows, uh, now we
Yeah.
have an imagination of how it goes, correct?
Mm-hmm.
So yes, going through the code, yeah, I have put my API key in my .env file. Okay,
Mm-hmm.
so that's my environment variable. So you need to do that first, and also you need to install a few of the libraries here. Okay, so that is
Okay.
LangChain Groq. Okay, so when we say LangChain Groq, like it's more like the Groq interface, but it is integrated with LangChain. LangChain has got its own wrapper. Okay, so since we are using chains, we are using LangChain in our application. So using
Mm-hmm.
the environment within the LangChain is great, right? So that's why. So I use the Groq wrapper. Okay, which handle like LangChain now has the so it will ask me for some keys and it will handle everything rest. Okay, I don't have to do the heavy lifting. So yes, so this was the simple interaction which I checked to check like my API key is working fine. Okay. So yes, so if you create like Groq API key, yeah, it's easy peasy, no worries. You can just go in and log in, and you can create your API keys. It's as simple as that. But yes, it takes sometimes to
Mm-hmm.
actually start working, be active. Okay. So I don't know if it is a glitch. I just checked through the internet and many have faced it. So it could be a glitch, but try to run this from the playground itself. And maybe like 15-20 minutes later, you can use it in your, let's say, VS Code. Okay. So yeah, so this I will, so here I'm directly dealing with Groq. Okay. So I have imported Groq. Okay. And I'm using Groq directly. So here, instead of this, I have used LangChain's wrapper. Okay, which will handle the response, let's say response code, everything much more precisely. Right. So yes. So how the flow goes is,
Yep.
okay. So here, this is my state. Okay. So type dictionary is the type here. Okay. This is basically dictionary, much more refined one. So here is the ticket. So that should be string. Category should be string. Context should be string, of course. Draft is like our email, right? So that should be definitely string. Critic agent is string and loop count is integer. So once the loop count exceeds 3, we will stop it. So here we have defined a simple function, which is actually supervisor node for us. Okay. So we pass a state here. So that's the memory, right? So we pass a memory in order to call this, right? My bad. Okay. Yes. So here it will start a like there's an LLM call happening. Okay. So analyze the customer support ticket, classify it as exactly one of this building technical or general. Okay. So now this particular supervisor node, right? Supervisor, let's say agent has to respond back with only it can respond back with only these three categories. That is building, technical, or general. Depending on that, my next pipeline is created. Okay. So here is chains. So LangChain has this name because chain within its name because so it allows me to like so this is a synchronous linear flow, right? So here, can I say the previous action is required to complete the next action? And there are certain actions, let's say 3 or 4 actions, right? Which has to be like in linear way. So the previous action is much dependent, right? So we can I connect it through chains, right? The previous thing has to be completed in order to get the next thing done. So there is a chain involved, right? So LangChain allows this chain concept where it can we can chain between two processes. Okay, if there is a dependency, we can chain between two processes, and unless the previous process is done, so it won't execute the next process, and once it's done, so it will execute the next process. So we have parallel chains and linear chains. Okay, serial chains and parallel chains. So here, for this particular application, so we've been reading serial chains. So yeah, that's fine. So this actually means chain. What I'm defining here is, so there is a prompt involved and I'm passing it to LLM. That's the process. Okay, this actually represents the pipeline here in LangChain's syntax. So it has to get the prompt and then it has to pass to LLM is what's been defined here. And once I invoke the chain, yeah, this happens. Okay, so this prompt is passed to this particular LLM call,
Mhm.
and yeah. So I will get the response as one of these three things. I will strip off everything and I will check only if in the response there is something called billing or technical or general, and I will extract it into category. So category variable has one of these now. And if it is billing, or yes, if a billing is contained within that response, right? So then it's a billing for me category. If not, if it is in technical, general, it's a simple code, right? So then I will respond back. I will update the dictionary as like for category, it is category. Okay, so this category variable will contain any one of these three particular terms. Okay, so now when this supervisor node runs, so category will be updated here. Understandable?
Yep, yep.
Yes, this retriever node is basically my rack. It's working. And this retriever.invoke is something which we have already done. So if you could see
Mhm.
back, so here where we designed our rack system, right? So here we have a retriever, which is connected to my vector store, correct? Vector store in the sense vector database. And it will pass me exactly like two variables, sorry, top two chunks, right? So that is the condition here. So I'm using the same retriever. So since I have, so these are all dependency codes, right? So I've run this already. So now I can use the retriever here. So which I have used. So retriever will actually invoke the retriever which we defined earlier, and it will pass me the state ticket. So ticket is something like user query. Okay, that's the ticket in this case. And depending on that, the response comes in, like the context comes in. So retrieved context, yeah, docs. So yes, we will be joining the docs and we will be creating context for it. And I'll be returning within the context key, right? So I'll be providing the context variable. So this is like updating it. Okay. Then comes the drafter node. So this is to construct an email. Okay, considering the policies, considering the user query, it has to write up an email. So that's the good part. And yes, so here if you could see, so you are a ZAPVI customer support agent, reply to this customer ticket and mentioned like the user ticket, okay, whatever he is going to provide. And rules, you must strictly follow the company policies provided here. So that's the context. Here the context comes in. The critic, yes, if critic is there, yeah, it will be written here, or else none will be there. Okay. So yeah, I mentioned it like if rewriting. Anyway, then comes a draft a professional email to the customer. Okay. So here if you could see again, here it's an LLM call, right? So that's why there is a chain involved. So the prompt comes in and LLM, so it passes, that prompt is passed to LLM. So yes, so I'll be passing it all, the context, the ticket, and the critic feedback, everything within a dictionary, and I will pass it as in like the context, the super context. Okay, and I will get the response. So return response.content, and I'll be processing this response. How we will see. So here is my last agent, that is critic agent, which actually got this from that you are in strict QA auditor for ZAPVI. We have provided the context that been fetched. So here we have provided the draft email that's been generated previously. Okay. Now, did the agents draft violate any policies? Okay, there is an example that's been provided. That's optional. Yeah, but LLM works good with example. So, so the second condition is if save output pass. If it violated the policy, output fail and explain the how we can fix it. Right. So that's a simple prompt, straightforward enough. And this prompt is passed to LLM, and we will get the response. So I'm passing that response into feedback variable, and I'm updating like feedback in the state. Okay, I'll be updating the feedback value. So yes, so here is my another node. So where it is deciding if it has to terminate the loop or pass it back to retriever again. Okay. So if the pass is the response from the critic agent, so yes, we will end the session. Okay, and we will respond back with a draft. If not, we will check how many counts it has been. If it is less than 3, if it is greater than 3, we'll stop it, or else we run it. Okay. So this return rewrite. So once this particular function responds back with rewrite, right? So this loops goes in again. So how we have defined it, we will see. So here it's a state graph workflow. So here I have added like all the nodes. Okay. So the first is the supervisor node. Okay. So basically my supervisor function, right? So I'm referring to that. So this is the node, and I'm just suggesting to LangChain what are my nodes and what are the chains. So this is my first node, the retriever node, the drafter node, and the critic agent, critic node. These are my nodes, and how I'm connecting it is supervisor is the first agent that will be triggered. So that is my first node to be triggered, and then comes the edge. So from supervisor, if the response comes from supervisor, it goes to retriever. Okay. So as you can see, so this is the first thing that will run, and this is the second thing that will run after the first thing is run. And then if the retriever responds, and after the response, what it should be. So there is an edge that's involved. So it's like connecting the points. So after the retrieval happens, so drafter comes in, and once the drafter is done, so critical comes in. And I've defined like what are the condition are. So from the critic, right? So if it is end, yeah, great, it's an end. If the response comes in as a rewrite, so we saw through that for particular function, right? So it responds back with rewrite. If it responds back with rewrite, so go to drafter. Okay, so this loop has to be like created here. So which we have defined here. Understandable?
Yep.
So once that's done, we will run the flow, and yes, that should be the case. So here we have used like LangGraph, LangChain, LangGraph are like for same family. LangChain is usually used for let's say LLM interaction or LLM orchestration directly. Okay, but LangGraph is used for Agentic AI. Okay, that's the like common difference, the generic difference between those. So yes, so we will be using chains in LangChain, but we will be using more of these nodes at edges, right? So these are available for LangGraph. So we'll be using LangGraph as it is an agentic AI workflow. So once this done, I have run it. Okay. So I haven't initiated anything now. So I have just made it live. Okay. In the next cell, I have put up one malicious prompt. So there is a ticket. I placed my order like 5 hours ago. Cancel it immediately and give me a full refund is my straightforward query. Okay, so that is my request, and this invokes so this particular ticket invokes my chain my agentic system, and now it has to process. So let's just see. So yes, there is a response here. So we'll just check through the response, and maybe we can run it later once again. Okay. So first, initially the supervisor is, so I'm printing printing everything. So it is categorizing it as billing because yes, he is asking for refund, right? So that's the billing section. So it is categorizing it as billing, and then the retriever comes in and the context retrieved. Are we printing it? Maybe not. Okay. And then the drafter comes in writing an email attempt one. So this is the critic agent. I have printed the whole critic agent. Okay. So auditing the draft against policies, and what is the response? Fail, because the agent's draft email does not explicitly state that cancellation request was made after 2 hours. Okay. But it does mention that order was placed 5 hours ago, which is outside allowed time frame. Okay. So basically, ZAPVI policies allows like once you put up order and it waits for 2 hours. So within that, if you put up like cancellation request, it will accept it. Okay. But here, as we can see in the ticket that's been generated, I placed my order 5 hours ago. But here he or she has not mentioned that whether they have requested for cancellation within 2 hours or not. Correct. So that is still it's not mentioned here. It's factual. So that's why the critic agent is saying. So that's why you can't actually. So let's say what's happening is we can imagine that drafter is trying to give the a complete refund. Okay, but the critic is stopping it and asking it to check through these points, and then it is reiterating. So here is the second attempt. The drafter has responded now. So what's the critic now? Fail. The agent's draft email does not contain yes, the same thing. It is going on loop. the email does not, yeah, it is more defined now. Okay, since it didn't understand the first flow, so it is more defined in the second flow. And it again reiterates, the loops goes in, and the draft email agent is now generating another draft, and the vertex is still failed, right? The agent's draft email did not explicitly state that the cancellation request was denied due to being outside two hours window, but instead offered an alternative solution to proceed with the orders. So again, this failed because we could print those responses now. Let me check, like, if I could print it. After agent, yes. Oh, we got a response here. Okay, now this should print even the email that's been generated. Okay, so as you can see, in the third time also it failed, correct? So it was still failed. So now what happened? That's why, as you can see, the agent's draft email did not express. Okay, the warning max loops reached escalating to human queue. But instead, what happened is, so here it was supposed to stop. So there is an flow error with my application here. So which I have kept it simply because I wanted to just present it the same. So what happened is here you can see there is a draft that's been created. So this could be like third iteration draft. Okay. So what's happening is, so there is a common memory which we are using, correct? Common state dictionary. So in that state dictionary, every time the draft comes in, right? So the draft is actually being written in that dictionary, correct? Before even it goes to critic, that is being updated. The dictionary is being updated. So ultimately, even when the three loops failed, I'm still printing like if there is something in the like email draft key, just put it. Okay, that was my command, and that's why even when it failed, so the last updated draft is being printed. So here my logical flow would be something like if the critic node still doesn't accept in the third iteration, I should actually remove everything from the draft email memory. But instead, here we are printing it. So that's a simple flow change which we can do. But let's just see through the last draft now. So thank you for reaching out to us regarding your place to ZAPVI. We appreciate your promptness in contacting us. After reviving, okay. The tutor's place file. According to our cancellation policy, we only accept cancellation 2 hours and date and time. Unfortunately, your cancellation request was made outside of this time frame. Okay, that's correct. Right. As per cancellation will not be accepted. We understand this may be inconvenient, but we must adhere to terms, conditions to ensure smooth and fair experience of customers. However, we would like to offer alternative solution. Sit with outer, we will ensure that it is delivered to you as soon as possible. It will have expected delivery. Yeah, this is like usual. Let's say Amazon or Flipkart's agent's response, right? Like, but here I can understand one thing. So the drafted email is actually correct, right? So it is accurate. It is not providing the full feedback,
Yeah.
full refund, right?
Mm-hmm.
But our critic agent is explicitly saying that yes, it is focusing on something, but it is the drafter email looks good. So can I say my
Yep.
critic agent is being at flaw here at this flow? I can conclude that, right? So yeah, even
Yep.
the critic agent could go rogue because again, it's an internally, it's both is an LLM call, right? Even the drafter agent and critic agent. So yes, so I'm not sure like why it is passing, sorry, why it is failing every time. But let's just rerun the same thing and let's check. Like my first iteration, it actually passed in the first attempt itself. Okay, it still failed. All right. So we can tune with the models again. So here, just a second. In the drafter, we actually try to print the response, right? But it didn't print. Not sure why. Okay, let me check with that.
Mhm.
So again, what we could do is we could update like the models. Let's just say that's lucky. If I go to playground here, all the models are visible. So I'll just choose bigger model. So we had like 8.1 billion tokens. So this is 70 billion. So let's just check with this particular LLM. Just update this. I'll just run this. So yes, the retrieve everything is being printed here, right? I think I didn't rerun this particular cell previously, which I'm doing now. So as you can see, so it is still classifying it as billing. That's great. And the node retrieved fetching brand policies from ChromaDB. Yes, the retrieved context. Here is the whole context. If you wanted to. And here is the subject. Cancellation request for order placed 5 hours ago. And so this is the first iteration. So now I'm printing the drafter email to correct. So so this is the first iteration. Dear customer name, thank you for reaching out. Yes, this may cost. However, we regret to inform you that unable to cancel your order as it has been more than 2 hours. This is good. Still good, I guess. Correct. So we have to check through like if it is offering some alternative, let's say brand discount or something later. Okay, that could be also termed as discount, right? As per our policy, cancellations are only accepted 2 hours ago since your order was placed. Okay. We understand this may not be open, but we hope to understand our policies are placed to ensure. Okay. Don't hesitate with us. Yeah. So yeah, this is good. Correct. So that's why the critic agent actually uploaded. It's pass. So yes, so this was a straightforward. There was no spicy elements here. Okay. Let me change back that previous model and let me see through the whole. So this is working good. I can rerun it. Okay. So every time the response could change, right? So let me check again. If you're still good, if it is still accepts in first go, we will change the model and we'll retry. Yes, it is way too good for our experimentation. Just the previous model run. Okay. So now I will run this. Okay. So there are more items that are happening now. Right. Yes. Context retrieved, writing an email. Yes. However, we regret to inform you that full refund at this time. According to cancellation policies, yes. Since you have placed 5 hours outside the time frame, able to trade status out. If you have a question, delivering. Okay. Okay, that's good. Yes, I have read the ZAPVI policies previously
Mhm.
while ordering it, so I know this. We value our business. Okay, yeah, this is good. The first iteration was good already, but let's see what the critic agent has to say here. So, critic agent auditing the draft. Okay, fail. The agent draft email does not explicitly state that the cancellation request was made. Okay. Okay. So, what critic agent is trying to say is, so the user is saying like he placed his order like 5 hours ago, but he hasn't mentioned in his query that he didn't initiate his let's say cancellation within 2 hours of that 5 hours. Okay, first 2 hour of that 5 hour, he can initiate the request, right? So within his particular ticket, right, he hasn't mentioned that he has not requested for 2 hours within 2 hours, right? So he has just said 5 hours ago he ordered it, and now he's writing that mail. So since the user didn't mention that he didn't put up cancellation within 2 hours or not, because of that, you can't simply assume. So what the critic agent is trying to say is, you can't simply assume that there was no cancellation request that's been put in the first 2 hours itself. So by considering that fact, this could go into flaw, right? Understandable, Saurabh?
Yep.
Yes, correct. So yeah, that was the explanation from critic agent, and so this should be something like it shouldn't have been accepted even in the next iteration. Considering this fact, right? So it is easy to assume that they may have not put up the cancellation policy. That's why the cancellation didn't happen. But yes, ideally, let's say with our ideal facts, yes, that's a fact. So instead of actually responding back with whether there should be refund or not, there should be a written query, right? Where it has to ask the user whether they have initiated the refund within the 2 hours or not. Right? That should be the ideal scenario. So yes, critic agent is thinking that way, and the drafter agent is actually creating these drafts this way. So there is a conflict, and even in the third iteration, yes, it failed. Okay, this has been printed like anyway, but yeah, we can ignore it for now. So yeah, it failed. So did we see the same thing in the other model which we checked? Did it accept it clearly? If it is pass, there is no explanation that's been provided, correct? I'll check. Category billing, yes. Apologies for any convenience is my cost. We regret to inform you that unable to cancel your order as it has been more than 2 hours since your order was placed. Yes, this still assuming that uh, the request wasn't made within 2 hours, and the critic is actually passing it without worries. So yeah, we thought our 8 billion parameter model was failing because it couldn't understand it. But yes, so it is factually correct, actually correct. But here the critic agent shouldn't have accepted this draft. Okay. So we can say that our critic agent needs much more fine tuning here. Maybe prompt addition, where we need to explicitly put up some rules which it should follow, right? Or we can put up some rules with the drafter agent which it should follow to make these responses much straighter. Okay. So yes, so there are some assumptions that are being taken by the drafter email. So yes, LLM tendency to be helpful, right? So that's why this happens. So yeah, that's it. So we have our backend ready now. So we have this application which we can run anytime. So I'll be sharing this code with you guys. Install the necessary libraries, install the necessary modules, put up your API keys, and it will be good to go with this.
Mm-hmm.
Right, sir?
Yeah.
Yeah. Sure, then that's for the day. So tomorrow we'll be checking on like the QA side of this particular application. Okay.
Okay.
Yeah, I will check through the board, and if I could export it, great. I will
Yeah,
share it
sure.
with you guys.
Let's see. Yeah.
Sure. Yeah, that's it. Any